Okay, so let's pick example 5 up where we left off. So we left off with x plus 1 minus 2x minus 2 all over that big complicated denominator. So we'll just do the subtraction. So I have, x plus 1 minus 2x minus 2. So I have x minus 2x. So that's negative x. Okay, so x minus 2x is negative x. And then 1 minus 2 is negative 1. So if I could factor out a negative sign from that, which would leave me with negative 1 times x plus 1. And this is all going to be over my denominator. X minus 1, x plus 1, x plus 1. And then I have this x plus 1 and this x plus 1 on the bottom and top. So I can just cancel out. So my final answer is going to be negative 1 over x minus 1 times x plus 1. And that will be my final answer. Okay, so now on to example number 6. So example number 6 is what's called complex fractions. So what that means is we have fractions with inside fractions. So I have this x over y plus 1, 1 minus y over x. Okay, so now I need to just basically make this into one thing. And so let's just look just at the top. So what's the common denominator of the top? Well, the common denominator of the top is y. So I'll multiply this by y over y. Y over y. So I'll be left with x plus y over y. And then if I just look at the bottom, the common denominator of the bottom is just x. So x over x. So I'm going to be left with x minus y over x. And now it's kind of like the division problems that we had before. So we do keep, change, flip. So I can do x plus y over y times, I'll flip it, x over x minus y. And I'm going to be left with x squared plus xy over xy minus y squared. Sorry if that's in the way. Still in the way. Let's try that. Okay. Now, on to number 7. Number 7 is another one of these complex fraction ones. It's almost a little bit less complex than number 6, though. So, because I just need to look at the top and figuring out what is the common denominator of the top. Okay, there we go. Okay, so what's the common denominator? I'm not going to look at the bottom right now. What's the common denominator of the top? Well, it's a plus h times a. So I need to multiply this by a over a. I need to multiply this by a plus h over a plus h. Okay. So this is going to be a minus a plus h all over a times a plus h. And then this is, once again, all over h. But a different way to write over h is going to be to say, well, over h is really the same as times 1 over h, right? So I'll just erase that. And now I can do some simplifying. So another way to write this a minus a plus h is I can just rewrite this as a minus, and I'm going to distribute the negative sign through, a minus h, but a minus a will cancel out, and I'm just going to be left with negative h over a times a plus h times 1 over h. Well, now, again, I have factors again, right? So I have this negative h and this h. So if I cancel those out, I'm just going to be left with negative 1 over a times a plus h. And that'll be my final answer for that one. And then on to number 8. So number 8 is going to be one of the most complicated ones we've done so far. It incorporates a lot of what we did in the last unit into stuff that we're doing in this unit now. So if I look at this, I see this and I go, oh no, I have to factor. But that's okay, I can factor, right? So I notice they both, if I look just at the top again, I'm just looking at the top, I see a 1 plus x squared and a 1 plus x squared. So I'm going to factor that out. And I'm going to say, well, it's 1 plus x squared, and my lowest power is to the negative 1/2. So if I take out a negative 1/2 out of this, I'm going to be left with, so if I subtract negative 1/2, it's really adding a half. So I'm going to be left with 1 plus x squared to the 1. So that's 1 plus x squared. I don't need to the 1, right? And then if I take out a negative 1/2 from this one, that goes away, so I'm just going to be left with x squared. But these parentheses, so I need to have parentheses around the whole thing, right? So, but these parentheses in here don't really do anything for me, so I can get rid of them. And I can say 1 plus x squared minus x squared. Well, that plus x squared minus x squared, that's going to cancel out, right? So I'm just going to be left with 1 inside that parentheses. And then this is all over. I can't forget about this 1 plus x squared. So then if I continue that onto my next slide, let me erase. Hang on, I'm erasing. Okay. So now if I continue that, here gets a little complicated. I have this 1 plus x, the negative 1/2, and I have this 1 plus x. I'm just going to use some of the properties of exponents I learned in section 1.2, because it's the same base. It's pretty complicated, but it's the same base. 1 plus x squared and 1, but I don't like the negative exponents, right? So I want to make it a positive exponent, so I can move it down. So I'm left with 1 on top, right, because I canceled everything else out, over, I have this 1 plus x squared to the first times 1 plus x squared to the 1/2 now. And these are the same thing, right? So I can add up my x. Wow, I was off the screen that whole time. So I can add up my exponents. So I have 1. So I have 1 over 1 plus x squared, and then I have a 1, and then I have a 1/2. So that's really to the 3/2. And that's it. Okay, so I'm going to hang off on example 9 for a second. So let's just say we had something like 3 over square root of 3. So mathematicians have decided a really, really long time ago that we don't like to have square root symbols in the denominator. There's no real reason for that other than that it becomes a pain. I don't really know off the top of my head what 3 over square root of 3 is. 3 divided by 1.7. I don't know what that is in my head. But what I'm going to do is I'm going to call rationalizing the denominator, and I'm going to show you how to do that. So what we do is we're just going to multiply both sides by, well, I don't want square root of 3 in there, so I'm going to take the same thing to get rid of square root of 3. So times the square root of 3 over, and I can always multiply by 1, so square root of 3 over the square root of 3 is just a different way to write 1, right? So now if I multiply this, I have 3 times the square root of 3 over, if I multiply these two together, I get it's the square root of 9. But I know that the square root of 9 is just 3, so I have 3 times the square root of 3 over 3. So I have 3 divided by the square root of 3, but the 3's cancel out, so it leaves me with the square root of 3. So now on to example 9. I have this, and once again I have this radical and then I have the square root. Sorry, calling it a radical is a bad habit. Radical is just that symbol. I should be more precise, call it a square root. So I have the square root in the in the denominator, and I don't like that. But if I just do my normal, if I just do square root of 2 over square root of 2, I'll get that it becomes the square root of 2 over the square root of 2 plus 2. And now that doesn't make it any simpler. So I have to figure out a different trick than just multiplying by the square root. So what I'm going to do is I'm going to go back to my knowledge about the difference of two squares. So if I took the difference of two squares, it always gets rid of a middle term for me, and that's what I need. So if I have a 1 plus the square root of 2, I need to multiply by 1 minus the square root of 2 over 1 minus the square root of 2. Okay? And these are called conjugates. So this and this are conjugates because they're the opposites, right? It's 1 plus the square root of 2, 1 minus the square root of 2. So what we're going to find when we multiply this out, I get 1 times 1 is 1. 1 times negative square root of 2 is negative square root of 2. 1 times positive square root is positive square root of 2. Those cancel each other out. And then I'm left with plus the square root of 2 times the square root of 2. So that's the square root of 4. So, but 1 plus the square root of 4 is really, or 1 minus the square root of 4 is really 1 minus 2, or negative 1. But I have to do the top, so I have to do 1 times 1 square root of 2 is 1 minus the square root of 2. So this I can rewrite as 1 minus the square root of 2 over 1 minus 2 is negative 1. Negative 1, I don't like that. That's kind of ugly. So I'm going to just rewrite that as negative 1. Right, when I divide by negative, it just flips the signs basically. So I get negative 1 plus the square root of 2, and it's over 1, so I don't need to write it. And then I'm going to skip example 10. Example 10 is pretty much the same thing as example 9, except it's rationalizing the numerator. Rationalizing the numerator doesn't really come into play until you get into calculus, so we're just going to skip that for now.